All right, this lesson in geometry is called Polyhedrons, Cross-Sections, Rotations, and Surface Area. This is also a new unit. It's called Unit 10, Three-Dimensional Measurements in Modeling. Okay. So a few definitions to start. The first definition is called a polyhedron. A polyhedron is a three-dimensional figure whose surfaces are polygons. Okay, it's called a polyhedron. Each polygon is called a face of the polyhedron. So if we look at this figure over here, this is an example of a face right here at the top. Okay, this is another example of a face, the right side. Okay, and then there's the face on the left, the bottom, the front, the back. Those are all called faces. An edge is a segment that is formed by the intersection of two faces. Okay, it's called an edge. For example, here's an example of an edge. Okay, that is the intersection of the face on the right and the face in the back. So that's an edge. And a vertex is a point where three or more edges intersect. Okay, a vertex. And this is important. You name a polyhedron based on the base. So we'll see that in example 1. Name each polyhedron below. Okay, so whenever you have a three-dimensional figure that comes to a point, see how this comes to a point and this comes to a point? That's called a pyramid. And you name it based on its base. So this base is a square. So this is called a square pyramid. Again, this polyhedron comes to a point, so it's a pyramid, and you name it based on the base. So the base is a hexagon, so this is called a hexagonal pyramid. Okay, now whenever you have a three-dimensional figure like this, where you have two parallel faces, it's called a prism. So this is a prism, and this is also a prism because you have the two parallel faces. Okay, and again, you name it based on the base. So the base is a triangle. See the triangle there, a triangle there. So this is called a triangular prism. And these bases are pentagons, so this is called a pentagonal prism. Okay. All right. Now we're going to talk about cross sections. A cross section is the intersection of a solid and a plane. It's called a cross section. You can think of a cross section as a very thin slice of the solid. Okay, so for example, this is a cylinder and this is a prism. Okay, a cross section is the intersection of a solid and a plane. Okay, so again, this is a cylinder and this is a plane. I don't know if I said that correctly just now. So you have a cylinder and a plane, wherever they intersect is called a cross section. Cross sections have many applications in the real world. They're used to study the anatomy of an eye. A cross section is the shape we get when we cut straight through an object. So for example, over here, I'm not sure how well you can see this on the screen, but over here you have a prism, a triangular prism. When you cut it down the middle, the cross section is a triangle. Okay? Look at another one. So a cross section is like a view into the inside of something made by cutting through it. In geometry, it is the shape made when a solid is cut through by a plane. So for example, another one. Let's say we have a cylinder and we cut it horizontally. The cross section is a circle. We don't draw the rest of the object, just the shape made when you cut through. Let's say we have a rectangular pyramid. Let's say we cut through it horizontally. The cross section is a rectangle. Cross sections are usually parallel to the base, but can be in any direction. So let's say this is called a torus, T-O-R-U-S. Okay, let's say we cut through it vertically. Let's say we cut through it vertically. The cross section is here and here. See? Let's say we cut through it this way. The cross section is this. Example 2. Describe the cross sections below. So we have a square prism. If we cut through it vertically like that, then the cross section is going to be a square. Over here we have a triangular prism. Let's say we cut through it like this. The cross section is going to be a triangle. Example 3. For the funnel shown, sketch each of the following. So this one says sketch it, so you have to draw a picture. A horizontal cross section. Let's say we cut through it horizontally. The cross section is going to be a circle. Part B, a vertical cross section that contains the axis of symmetry. So in case you don't know what that means a line through the shape so that each side is a mirror image. A line through a shape so that each side is a mirror image. So if I were to perform a vertical cross section that goes through the axis of symmetry, it would look like this. Let's see if I can draw this. Something like that. It's close enough. Okay, this next example is a little tricky one. What is the resulting 3D shape that you get from rotating the 2D shape about the given line? Okay. So there's 5 three-dimensional shapes we're going to do in this unit. Let me write them down here. Okay. We are going to do the following 3-dimensional shapes. We're going to do prisms. We're going to do cylinders. We're going to do pyramids. We're going to do cones. And we're going to do spheres. You've seen each of these before, not in this class, but you've seen each of them before. So the answer to this question is going to be one of those 5 three-dimensional shapes, because those are the 5 we're going to do in this class. So this is tricky. I'm going to try to take this shape. It's in 2 dimensions right now. I'm going to try to draw it in 3 dimensions. Okay, so here, let me try this. Let me start by drawing that triangle. If I rotate it along this line, okay, let's take this point right here. This point is going to stay on the line. It's going to rotate to itself. Let's take this point. If I rotate it along the line, let's see what happens. It's going to rotate around like this. Let's take this point. If I rotate it along the line, rotate like that, it's going to come right back around. So maybe you can see the shape that's forming. It's a cone. This is a cone. Think of an ice cream cone. Kind of looks like an ice cream cone. So the resulting 3D shape is a cone. All right, next page. 3 more pages, 3 more examples. I want to go back, I want to talk about prisms more. A prism is a polyhedron with exactly 2 congruent parallel faces called bases. We talked about this a little bit earlier today. The other faces are called lateral faces. You name a prism by the shape of its bases. Okay, so these are the bases. They're the parallel faces. Okay, bases. And the other faces are called lateral faces. An altitude of a prism is a perpendicular segment that joins the planes of the bases. The height of a prism is the length of an altitude. The lateral area of a prism is the sum of the areas of the lateral faces. I'm not going to do too much with that. I just want to give you that definition. We're going to focus on the next definition, which is the surface area is the sum of the lateral area and the area of the 2 bases. Basically, it means you add up the area of each face. Okay? So example 5, find the surface area of the rectangular prism. We have 6 faces, the face in the front, the right, the back, the left, the top, and the bottom. We have to find the area of each face and then add them all together to get the surface area. Okay? So let's start with the top face and the bottom face. They're rectangles, so the area formula is going to be base times height, so 9 times 7. 63. 9 times 7 equals 63. Now let's do the face on the right and the face on the left. It's going to be 7 times 14. That equals 98. Okay, so we did the face on the bottom, the face on the top. We did the face on the right and the face on the left. Now let's do the face in the front and the back. So the front face is going to be 9 times 14, because this 14 is the same as that 14. 9 times 14 equals 126. So for the surface area, I'm going to add up those 6 faces. 63 plus 63 plus 98 plus 98 plus 126 plus 126. It equals 574 feet squared, because we're not doing volume yet. We're still on area, surface area, so it's still feet squared. Once we get to volume, it'll be cubic units. That'll be the next lesson. Example 6, find the surface area of the triangular prism. So let's start with the face in the front and the face in the back. These are going to be the same. So I'm going to do, it's a triangle, so 1/2 base times height. So 1/2 times 4 times 3. That equals 6. That's the same for the front and the back. So I'm just going to write it twice. Now let's do the face. Let's do the one, like this diagonal one. It's a rectangle, so base times height. 5 times 11 is 55. Now let's do the face in the back. That's 3 by 11. Okay, so 3 times 11 is 33. And we have one more face. The one on the bottom is 4 by 11. So 4 times 11 is 44. Now we're going to add up those 5 faces. Surface area equals 6 plus 6 plus 55 plus 33 plus 44. Equals 144 centimeters squared. Okay, so we talked about this before. Like a prism, a cylinder has 2 congruent parallel bases. An altitude of a cylinder is a perpendicular segment that joins the planes of the bases. The height of a cylinder is the length of an altitude. Okay, so again, look, this is the base, and that's a base. This is a base, and that's a base. We're going to do a surface area of a cylinder, just like we did the surface area of a prism just now. But there is a formula that you can use for the surface area of a cylinder, because for a cylinder, the bases, are always circles. So here's your formula. Surface area equals 2 times pi times radius times height plus 2 times pi times radius squared. This is the surface area formula for any cylinder. And this is what the last example is based off of. Example 7, find the surface area of the cylinder. I'm just going to copy down the formula that we just saw on the bottom of the previous page. 2 times pi times radius times height plus 2 times pi times radius squared. Okay, we're going to do our answer 2 ways for this problem. We're going to do it in terms of pi and as a decimal. Okay, so let's do the answer both ways. Now, I think it should be pretty clear from the diagram that the height is going to be 10, and the radius is not 16, The radius is going to be 8, okay? So surface area equals 2, leave the pi there. The radius is 8, and the height is 10. Plus 2 times pi times the radius, which is 8 squared. Now let's clean this up. We're going to leave the answer two ways, with pi and as a decimal. So this first part, multiply everything but the pi and leave the pi alone. 2 times 8 is 16, times 10 is 160 pi. Okay, 2 times 8 is 16, times 10 is 160 pi. Plus 8 squared is 64, times 2 is 128 pi. Now we're going to add these two numbers together, leave the pi there, okay? 160 plus 128 is 288 pi inches squared. And then let's actually multiply that out on our calculator to get a decimal. 288 times pi, 904.8. So the answer both ways. Inches squared because we're still doing area today. And that's the end of that lesson. There was a lot in that lesson. Polyhedrons, cross sections, rotations, and surface area.